this video, we're going to talk about one applied example of a function of more than one variable. So this example comes from the Journal of Experimental Botany, and the citation for the paper is all up here for us. So this had to do with mung bean seed germination. So the experimenters were germinating mung bean seeds, and they were changing two variables and seeing how that affected the days it took for the seeds to germinate. So they were changing the temperature of the greenhouse and the water potential, which is something we'll talk about in a minute. And what they came up with after doing that and measuring how many days it took was this equation. So let's define what all this is. So g of t, and this second variable is called psi. It's a Greek letter. PSI is the way it's written in English letters. Some people say psi, some people say psi. And it is the days, and it's median days to germination of these mung bean seeds, where T is the temperature in degrees Celsius, and that psi is the water potential. And it's measured in something called megapascals. So the water potential is sort of a measure of how much water, how much moisture is available for the seeds in the soil. So this is the equation that they came up with, and it's an equation of these two variables, t and psi. So we're going to do one example of it and then talk a little bit more about how this function works in a minute. So let's try something like, suppose our temp is 24 degrees Celsius. So that's right around 75 degrees Fahrenheit. And the water potential is minus 1 megapascals. So we're going to use that to figure out the median days to germination. So this is just a plugging in problem like we saw in the earlier video. So we're plugging in 24 for our t and our -1 for our psi. All right, so we're plugging in g of 24 -1, and we're using that equation right up there. So we've got 15 minus 24.2 times -1 over our t was 24 minus 10.1. And if we plug all that in, we get 2.8. For our days. All right. So let's talk about this equation a little bit more. And you'll be studying this more in the face-to-face sessions coming up. So one thing that's important about this is when we have an equation like this that's coming from a real-life situation, like these seeds germinating, there are only certain values of the variables that make sense. So in terms of the function itself, we could plug in something like t equals 0, and that would be fine. What we would get out of that denominator is -10.1, right? And we can plug that in and get a number out of this. We'll probably get a negative if we have a negative water potential like we saw in our example there. We'll get a negative number out of this. But if we put that in context, it makes absolutely no sense on multiple fronts, right? So days to germination being a negative doesn't really make sense. And t being 0 is no good for this function, and that's why we're getting this weird value that doesn't make any sense out of the function. Because 0 degrees Celsius is freezing. So if your greenhouse is at the freezing point of water, then the seeds are not going to germinate, right? So whenever we have an equation like this that's coming from a situation in real life. We always have to pay attention to that sort of thing. What are the limitations on this? What are the variables? What are the values for the variables that make sense, and what are the values that don't? So we'll study this one a little bit more coming up.